Okay, for the past maybe week, I've been working on the Cpap Flap, and this was something that I originally saw by Vitals, or Vitals, or however you say it, on printables. And this method is, allows your Cpap blower's inlet to go here, and then when you're at 0%, this flapper blocks off the outlet, and then that air has to travel through here and out this orifice here into atmosphere, so that you get zero pressure at your cooling duct when you're at 0%. And the original remix, so I've only been working with the remix, which is this one here. It's similar to the Vitali duct, but in using this particular flapper, the pressure curve was this line here. Okay, you see it comes up quick, and then it just goes flat, 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 and then increases here. So I wanted to change it up a little bit. This particular remix had the orifice size too small here and on the outlets. Also, the center approach here and the flapper at an angle didn't really have a straight shot for that air. So I went and made this guy here, and I blocked off this area here, and there's an orifice basically right here between that flapper and that wall. And as this closes, it's going to slowly pinch off that bleed that's right here. You've got a bleed that goes in the out here. You put a cap on there. It's got the right size bleed hole on it. This one's for this, not going to fit, but anyway, you put that on there, and that controls your outlet. Your bleed outlet is typically your total volume of your duct's outlet. And so this was my second revision, and I used some little TPU filament inside here to seal around that edge of that flapper movement there. And so that just swings like that. Now, because that range is so much shorter, it becomes a little bit more responsive. So then that leads us to this guy, which was the last one I made. It's just not a regular flapper there. It's kind of got a bulge on it. And then there's an orifice right there in between there. And as that closes off, it's going to close that orifice pretty quickly, so you can get so you're not basically bleeding out that orifice. It's going to give you more pressure, more volume's going to come out that tube. And then of course the inlet and outlet is a straight shot. Let's do this like this, okay? So this was my second iteration of this, and what it basically gave me was this red line. Okay, but it tapped out right here around 55%. That was it. So then what I did is I rescaled this so that it would fit in the 0 to 100%. And so the scaled is this lime color here. And then this blue one is the original Cpap test. That's the original. And here we're looking at grams of force on a jeweler scale, and this is our 0 to 100%. So this is really pretty close to regular Cpap, other than it's got a little bit less pressure, which means it has a little less volume, which means it's not going to be as good as the straight Cpap, because we've got losses here. We've got a pressure drop across this, so we're gonna lose some of our effort just in the contraption. And so then I get it working pretty decent, and then I went to use MPC calibrates that I could have this go at different fan percentages to get my ambient or my fan coefficients. And during the MPC test, the actuator would not move. and that's because MPC Calibrate does not call an M106, and in my case, to move this as a manual stepper, it's using an M106 to take the value for cooling and then convert that into a position, basically, to move the flapper here. So I ended up having to modify the control.mpc.py file so that MPC would move it during the calibration, and I was able to do that, and I was able to calibrate you know, during the MPC calibrate. I was able to get the fan constants, and then, you know, I was great. Well, then I wanted to go ahead and print something, and so I printed two of these models, one with the Cpap and one without the Cpap. And let's see here, which is this one? Okay, so this is the one with regular Cpap. Let's try to show that. Let me get a flashlight here. This is regular Cpap. And then I printed the same G-code file with the flapper. And this is what I got. The same on both sides. And this is every time the flapper moves to another position, this is the effect that it has. And the reason for that is that even though the manual stepper function has a sync 0 parameter, in other words, so that it will not try to sync that to an axis, it does anyway. And so what it does is basically throws the kinematics off on your XY movement because you commanded a stepper function, and Klipper's not quite meant to do that. So a way around that would be to put maybe you could still use a stepper, but I think it's possible to take the PWM value and then convert that to a step value, and then go ahead and send that to the stepper, like use the Raspberry Pi to monitor that, and then output those changes without submitting that to any kind of G-code. Because if you run a little test of run your X back and forth really fast, and you throw an M106 in there, it's going to be fine. But then you throw in that stepper logic to move that stepper, and it hiccups when it goes back and forth. So at this time I can't really test it because it doesn't work yet. I'm going to have to see if that's something I want to go a little further with. But at this time it's not working yet. So anyway, I was hoping to try it. You know, I really did not look forward to having the blower on 100% and making a print. But I did want to kind of see, you know, did it have a better effect? Was it something that I could use? Could I put that in place and then, you know, disable it and use the regular Cpap? And then when I felt like I wanted to have that, I could just switch that, you know, with the macro. But at this time, I really can't use it, just because I've got it connected as a manual stepper. So, and from what I read, I don't know that I can fix it very easily. I'm going to have to do something else in order to get that to work. So if you've got a manual flapper like this, a manual stepper, and you're trying to run the Cpap Flap, watch out, because it can definitely cause some hiccups in your prints. So anyway, that's what I got. Until next time.